Hey, everybody. Welcome to my basement. It's been a long time since I've seen you, and I want you to know that Carly is doing great. If you want to see her, she will be at my office hours on Tuesday. It's the only day she's going to show up. All right, so make sure that you spread the word if you want to see her. All right, today we're starting a new unit. All right, our unit is on probability. It's something that I use every day. I have to weigh what could happen versus what could happen versus something else that could happen in a situation. All right, so we're going to look at probability, including some vocabulary words that you're going to see in this entire unit. Come on, there we go. All right, any activity that involves chance, such as rolling a cube or dice, is called an experiment. Before we roll dice, we don't know what numbers they will land on. There's a bunch of different numbers they could land on, right? We can guess, but we can't be absolutely sure of what they will land on unless they're trick dice or you have a dice or multiple dice that all have the same number on it, right? So a traditional standard dice, and one is called a die, right? So a traditional standard die has the numbers 1 through 6 on it. But if you had one that just had 3s on it, then it wouldn't be an experiment. So here's a picture of a couple of dice, right? So after they've been rolled, one lands on a 1, and this one is going to land on a 4. But before we rolled, there was a chance that one would land on a 4, but it didn't have to land on a 4. It could have landed on 2 or 3 or 4, or well, not 4, 5 or 6, right? Rolling dice is an experiment because we aren't absolutely sure before we roll the dice what it will land on. We can hope for things, but we can't be absolutely sure. Flipping a two-headed coin is not an experiment. It's not an experiment because when you flip that coin, you know that it's going to land on heads. There's no other option. And that includes the edge of the coin. You could flip a coin 1,000 times and it will never land on an edge. If you don't believe me, after you finish all of your homework in math and science and Minnesota studies and reading and writing and your elective classes, try it. Keep on flipping a coin until it lands on an edge, all right? I'll see you next week still trying to flip that coin. Okay, in math, when we talk about the probability of an event, we write it as P of the event. So if I'm flipping a coin, I would write capital P for probability, and you can see it's kind of sideways, italicized. So the probability of flipping a coin is the measure of how likely an event is to occur. And quite honestly, I wouldn't say probability of flipping of a coin. I'd say the probability of heads or the probability of tails. All right, so speaking of that one, taking a look at our number line, where do you think flipping a coin would be? Is it over here at 0, impossible? Is it impossible to get heads on a regular standard coin? Do you have to get heads on a regular, not a trick coin? Right. Ideally, you'd say, well, no, it's not impossible because there's a head on a coin, and it's not certain because on a regular coin, there's also tails. So, the probability of heads or the probability of tails is going to be in between 0 and 1, and it's going to be right here in the middle. Here's 50%. I know that it's going to be in the middle because there are 2 possible outcomes. That's the denominator of our fraction. And one of them is heads, or one of them is tails, right? So 1 out of 2 sides is heads, 1 out of 2 sides is tails. So we would call that the fraction 1/2, but the way that we read it in probability is 1 out of 2. Right? And if you look down below, here's the decimal 0 and 5/10. That is the decimal form of 1/2 and 50%. We'd call that an even or a 50-50 chance. The other thing that you would hear is as likely as not. It is as likely to flip heads as it is to flip tails on a regular standard coin. Now we're going to go over to the left. We're going to go to the right side and talk about 100%. Right? If you look straight down, there's an arrow pointing at this exact spot on the number line. Only right here is 100%. All right, that's the decimal, even though there isn't a decimal point. That's the decimal 1. Remember, we could write 1 decimal point and as many zeros as we wanted, right? And the word that goes along with that is certain. If you had a 2-headed trick coin, you are certain to land on heads. It doesn't matter how many times you flip the coin, it is always going to land on heads. That word is certain. right? So that's 100%. And you see hashtag on top of hashtag. But remember, in math class, that's not hashtag, that's the number sign, right? So if this was our experiment for flipping a coin, we would say 2 out of the 2 sides, excuse me, 2 out of the 2 sides have heads on them. So that would be the fraction 2 halves. Again, we'd say 2 out of 2, and that simplifies to 1 whole. 2 halves makes a whole, right? It's not always going to be 2 on top of 2, but using a coin is probably the best example for just introducing this. On the other side of the number line is the word impossible. If I'm flipping a 2-headed coin, it's impossible for me to get tails because 0, I'm at the fraction now, 0 out of 2 of the sides have tails. 0 on top of 2 is 0 halves, and that simplifies to the number 0. Again, this is the decimal. I could add a point 0.0000000, right? So that's why this is still a decimal. And 0 is the same as 0%, right? But now we have some words underneath our number line. Here's the word unlikely. Do you see how it's underneath 0 and 25 hundredths? 0 and 25 hundredths is unlikely, but any spot in this entire blue bar is also unlikely. Anything more than 0, but less than 1/2. Anything between 0% and 50%. Anything between 0 and 1/2. So 33% is unlikely. 2% is unlikely. 49% is unlikely. It's got to be more than 0, but less than 50%. And on the other side of our number line is the word likely. And again, you see that that's below 0 and 75 hundredths. That's not the only number that's likely. It's this entire purple bar. And if I was going to redo this, I'd make the purple bar go right up next to that little black line and right up next to this little black line. Because anything in between 50% and 100%, anything between 1/2 and 1 is classified as likely. So again, not 50%, because exactly 50% is even 50-50 chance or as likely as not. Exactly 100% is certain, but 99% is likely. 99.9999999% is likely. You might say very, very likely, but it's still likely, not certain. 50.0000002% is likely because that is more than 50. All right. The next thing we're going to look at is some classic probability problems, and you're going to see problems like these pop up throughout our unit. So the very first one is an even chance, a 1 in 2 chance. That's the coins that I keep mentioning, right? One of the 2 sides is heads. One of the 2 sides is tails. That's why it's an even chance, right? There's an equal amount of heads and an equal amount of tails on each fair coin, not a trick coin. Another probability problem that you will see that I've mentioned already is dice. Each number shows up once on a standard die. So there's 1 1, there's 1 2, there's 1 4, there's a 1 in 6 chance that I'll roll a 1. There's a 1 in 6 chance that I'll roll a 3. And then our last example on this page is marbles. So there are 1, 2, 3, 4, 5 marbles. If you were going to pick a marble, there's a 4 in 5 chance that you would pick a blue marble. So it'd be likely that you would pick a blue marble, right? If I wanted to roll a 2 and I had to roll a 2 to win a board game, it would be unlikely that I would roll a 2 because only 1 out of those 6 is a 2. There are 5 other numbers here, right? I'm more likely to roll one of those other numbers than I am to roll a 2, but I could roll a 2. So it's unlikely, but not impossible. Okay, we're going to look at a couple of examples from your assignment. So when this video is over, please upload this PDF into Notability, right? We're only going to look at a couple of the problems and then you'll need to finish them. All right, so the directions say write impossible, unlikely, as likely as not, likely, or certain to describe each event, right? So I'm going to list a whole bunch of different things that could happen, and you have to pick one of those options. We're going to start with number 1. This year has 12 months. Is that impossible, unlikely, as likely as not, likely, or certain? I might end up sneezing here. You remember how often I do that. Maybe one more. Maybe not. All right, so let's look at that again. This year has 12 months. The word for that is certain. Every year has 12 months. We don't just randomly skip February or March, as much as it would have been really nice to skip March this year with the pandemic, right? And if we were skipping July, I would be really upset because I wait a really long time for summer to show up. I want to run around outside in shorts and a t-shirt and play games with Carly, all right? So if July doesn't happen, I'm really going to be upset, right? However, I don't have to worry about it because every year has 12 months. So that word is certain. The next problem we're going to look at is number 4. The spinner at right lands on blue. So here's our spinner, all right? Imagine that you use your finger and flick the spinner and it spins around and around and around and around and around. Can it land on blue? I don't think it can. Here's orange, red, green, yellow, and purple, but no blue, right? So the word for number 4 is impossible. No matter how many times you spin that spinner, it's never going to land on blue. So that's impossible. And the last one we're going to look at is number 6. So number 5 and 6 don't use the spinner, but number 3 and 4 do, right? So don't try and use the spinner for number 5 or 6. For number 6, you correctly guess one of 8 winning numbers between, oh, I made a mistake here. Let's see if I can get my tools back. Oh, I can't. I lost them. It's just the first time that I've really use this. Can you imagine that it says the winning numbers between 1 and 10? I will try to fix your copy. You correctly guess one of 8 winning numbers between 1 and 10. It is likely that you will pick that. And here's what this really means. I wrote out the numbers between 1 and 10. 1, 2, 3, 4, 5, 6, 7, 8, and 10. Every blue number is a winner. So if these numbers were randomly in a bag and you closed your eyes and you picked out a number, right? Of the 10, 8 of those choices would win you a prize. So you are likely to win a prize because there are only 2 numbers where you would be a loser, where you wouldn't win the prize. And there'd be 8 numbers where you'd be a winner and you would win the prize. So it is very likely. You will need to do 2, 3, and 5 on your own. All right, looking at the next section. The probability of winning a game is not 2/3, read that as 2 out of 3. So if there was an equal chance, if you were as likely to win as you were to lose, it wouldn't be 2 out of 3. I'd need half of 3. Half of 3 is 1.5. So because 2 is more than 3, this is more than 1/2. And you know that. If you ate 2/3 of a cookie, you're eating more than half of a cookie. So the word here is likely, right? There's still a chance that you won't win because we don't have the same number for the numerator as we do for the denominator. Right? And the last one, I was sure that I fixed this on here, but it looks like I didn't. I just don't understand. It says there is a 50% chance of, it says snow on mine. I changed it so it's rain on yours. All right, so imagine this says rain. There is a 50% chance of rain today. Well, what does 50% mean? 50% means half, right? And that word that came at half was as likely as not. Okay. We could say there's an equal chance of rain as there is of it not raining. So that's why it's as likely as not. Okay, moving on to the next section. Here's 11, 12, and 13. We are just going to do number 11. Suppose the chance of reaching into a bag of coins and selecting a quarter is 40%. Write this probability as a decimal and as a fraction. So this problem is really as easy as it sounds like it is. The very first thing I'm going to do is write 40% as a fraction. 40 for the numerator, 100 as a denominator. I can write it as 40 on top of 100, or I could simplify it and write it as 4/10 or 4 out of 10, right? For the second one, it said also as a decimal. So 40% is the same as 0 and 40 hundredths. Remember, if you read that as 40 hundredths and not 0.40, then it's really easy to go between 40 100ths and 40 hundredths as a decimal. Or 0 and 4/10, which is also here, all right? For this unit, we're going to simplify everything, all right? So the best answer on this side is 4/10 as a fraction, and the best answer on this side is 0 and 4/10 as a decimal. You need to do number 12 and 13 on your own. All right, there's another page in your PDF. At the very top, it's talking about blood donations, right? There are 8 different human blood types, and that's shown down here in this graphic. This graphic is going to be used for problem 15, 16, 17, and 18. We're not going to do number 19. Make sure you read this top part because it's pretty interesting. I'm going to do number 15 for you, but you will need to do number 16, 17, and 18. All right, so here's number 15. How would you describe the probability of a person having AB positive blood? Impossible, unlikely, as likely as not, likely or certain. Also notice there's the word explain. So I'm expecting at least one complete sentence. So my work is down here. So notice here's my arrow saying, yep, I'm going to look in this picture and I'm going to look for AB positive. So I put a little box around it. It's not super easy to read, all right, but you can do it. It says AB positive, comma, 3%. So now I'm going to think 3%, is that impossible? No, because impossible is 0%. Is it certain? No, because certain is 100%. Is it as likely as not? Nope, it's 50%. So it's either likely or unlikely. So here's my answer. A person is unlikely to have AB positive blood because 3% is very close to 0%, which is impossible. So it's not impossible, but it's unlikely. All right, so you need to answer questions 16, 17, and 18. When you finish, you can go through the slides until you find my video that has the answers on it. Compare your answers to my answers, and then upload your work to Schoology after you get a chance to complete your work. If you have any questions, please make sure to meet me in office hours. I'm a little distracted. I'm not sure if you can tell. Carly just woke up and is sleeping upstairs. All right. So again, you need to complete the worksheet on your own. I will see you in the answer key.